We're going to talk about in 12.7 determinants. So in here, we're going to try to just basically figure out what is a determinant, how do you evaluate it, and then in a later video, we'll talk about what can we use them for. So what we get is an array of numbers. So here we see, we go horizontally, we call those rows, and vertically we call those columns. So this we would say is a 2-row by 2-column determinant. The A1, A2 is row 1, the B1, B2 is row 2, A1, B1 is column 1, A2, B2 is column 2. Determinants are always what we call square, so they always have to have the same number of rows as they do columns. So determinant is equal to a number. So we would say, if I called this determinant, say, I'm just going to bring another color in so we can see it. So if we call that A, then we could say the determinant of A is, and the way we evaluate that is we multiply down the diagonal. So that's A1 times B2, and then we subtract what we go up the diagonal. And so that's minus A2B1. And that's how we're going to evaluate a 2 by 2 determinant. And again, that is going to be a number. So let's do an example of one here with actual numbers in it. So suppose we had 3, -1 is the first row, and 2 and 4 is the second row. So to evaluate this, we would go down the main diagonal here. So that's going to equal 3 times 4 minus, we're going to go up the diagonal here. That's going to be 3 times -1. And so that's going to be 12, and that'll become a plus 3 is 15. So we're always going to get a number. Could be positive, could be negative, could be 0. And some of these will have some significance, but we'll talk about that a little bit later. So let's talk about, let's move on to 3 by 3 determinants. So in this case, we're going to see that there are actually 2 different ways of evaluating these. So there will be 2 ways to evaluate 3 by 3s. One of them works only for 3 by 3s. And the second method is the more general method that works for all determinants of all sizes. So I'm going to do method 1 first. Is going to be only works for 3 by 3s. So it's kind of a special method for only 3 by 3s. So if we do say, I'm going to go absolute, it looks like an absolute value, but that's a determinant symbol. And so if I go 2, 1, -1, 1, 3, 2, -2, 2, and 1. So there is our 3 by 3 determinant. So what we are going to do in this case is we're going to recopy the first 2 columns right next to each other. And you want to try to keep your spacing pretty good and take a moment to do it as accurate as you can, because we're going to need to be able to see what we're doing with these. Now, once we've recopied those, we're going to go down, 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 and we're going to multiply those 3 numbers together and add their products. So 2 times 3 times 1 is 6, plus 1 times 2 is 2 times -2 is -4, plus -1 times 1 is -1 times 2 is -2. Then we're going to go up the diagonals and subtract. So we're going to go minus, minus, minus. So that's going to be, let's see, -2 times 3, -6 times -1 is positive 6. We're going to go minus 6. And then minus, let's see, 2, 2, 2 is 8. And then minus 1, 1, 1 is 1. So our final result then is going to be that we're going to get this 6 plus -4 is 2, minus 2 is 0 we got from that part. And then we're going to add to that the -15. And so our determinant is going to be the number -15. So that's one way of doing a 3 by 3 determinant. So let's look at the second way of doing this. Or actually, let's do one together. We'll do one more. I'm going to get a new screen here. So let's do this one. Let's say we have 1, 0, 5, negative 2, 1, 3, and let's say negative 1, 2, and 4. So we're going to evaluate this. So if you want to pause it, you can work it on your own, and then you can see if we get the same thing. So I'm going to recopy 1, negative 2, negative 1, and 0, 1, 2. And then we're going to go down the main diagonal. So we're going to go down, down, down. Try not to cross out the numbers as we do this. So that's 4 plus 0, and then that's going to be let's see, negative 10, negative 20. And then we're going to go minus and then up the diagonal here. And up the diagonal here and up the diagonal here. So that's going to be a minus, looks like negative 5. And then a minus 2, 3, 1 is 6. And minus, we got a 0 in there, so that'll be 0. So our final answer for this determinant is going to be 4, let's see, negative 20, negative 31, and 4 will be a negative 27, I believe. Okay, so now let's talk about method 2. So this is the more general method that's going to apply to any determinant of any size. So this is called expansion by minors. So we're going to have to talk about what we mean by a minor. Expansion by minors. And so this is our general method. So a general method that works for all determinants, even back to the 2 by 2s. Okay, so we have to talk about some different parts of this. First of all, in any determinant, there is a sign associated with its position. So this first place is the row 1, column 1 entry. So that position is always considered a positive. You'll see where this comes in a moment. And then we're going to alternate signs. So in the case of a 3 by 3, it would go positive, negative, positive. And it alternates going in both directions. So negative, positive, negative, positive, negative, positive. Okay, so those signs are associated with its position. Now, there's also the idea of a minor. So what we mean by a minor is if I have, say, I'm going to go, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's our 3 by 3, but this could be any size determinant. So the minor of a particular position is the row and column, is you delete the row and column that it's in, and you take the determinant of one order less. So if I look at 1, if we delete the row and the column that 1 is in, then I'm going to say 1's minor, the minor associated with that row 1, column 1 position, is going to be a 2 by 2 that goes 5, 6, 8, 9. Now that works for any position. So for example, if I choose 5, then I can say 5's minor is going to be the determinant I get by crossing out the row and the column that 5 sits in, and the other terms that survive make up that determinant of one size less. So it would be 1, 3, 7, 9. Okay, now with that in mind, what we are going to do is we are going to choose to expand along the row or column of our choice. So we can expand along any row or any column. And sometimes one will be more advantageous than another, one that has more zeros. We will use the sign pattern only for the row or column that we expand along. Okay, let's see what this might look like in an example. I'm going to explain it through an example. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, just for the sake of argument, I'm going to expand along row 1. So what we need first is the signs that go with row 1. So we know they start positive and they alternate in sign. So what that means is we're going to get a +1, a positive, meaning leave the same sign as that first row 1, column 1 entry, times, and now what we're going to do is the minor, whoops, I didn't want to make that an eraser. Let me put back the 3 that was there. And what we're going to do is delete the row and the column that 1 is in, and we will write down its minor 5, 6, 8, 9. And then we're going to go on. So now we're going to go to the next term. So now we're going to take the minus, and then that number, that term that is right in that row that we're expanding along, 2 times, and then we're going to get 2's minor. So we are going to cross out the row and the column that 2 is in, and we will write what survives. So that's going to be the 4, 6, 7, 9, and I left off the 2. Oh, I put it in the wrong place. 4, 6, 7, 9. So it's going to be 4, 6, 7, 9. So that is going to go there. And then we continue our expansion. So now we are up to the plus, and we take the face value of that entry in the row 1, column 3 slot. That's going to be our 3. And then we are going to take 3's minor. So we're going to delete the row and the column that 3 is in, and we will write what remains, the 4, 5, 7, 8. 4, 5, 7, 8 is its minor. Now, when we evaluate this, we're evaluating our 3 by 3 determinant. So remember, we're going to get 1 times, and now the way we evaluate these 2 by 2's is we go down minus up. So that is going to be 5 times 9 minus 8 times 6. Whoops. So that's going to be its minor. And then we go minus 2 times, and again we go down minus up. So that's 4 times 9 minus 7 times 6. And then we get a plus 3 times, and then here we go down 4 times 8 minus up 7 times 5. And there needs to be a parentheses, not an absolute value. Okay, so now the arithmetic. So we have 1 times, and that's going to be 45 minus 48, I believe, which is going to be a negative 3. And we're going to get a negative 2 times, that's 36 minus 42. 36 minus 42 is a negative 6. Negative 2 times a negative 6 is going to be a positive 12. We're going to get 3 times, looks like 32 minus 35. That's going to be 3 times a negative 3. That's going to be a minus 9. And so it works out to be 0. How about that? All that work and we got 0. Okay, so now big picture then is if you get something bigger than a 3 by 3, which we won't do very often unless it is a very carefully selected one. So suppose we have a 4 by 4, say 1, 0, negative 1, 2, 0, 2, 1, 0, and 1, 0, 2, 3, and then let's go, let's go negative 1, 0, 1, 2. So there's our 4 by 4. Now, we can choose, remember, any row or column to expand along. So when we do this, we search for the row or column that has the most zeros. So row 1's got 1 0, 2 zeros, 1 0, 1 0. Column 1 has 1 0. Here's 3 zeros, no zeros, 1 0. So we are going to choose the row or column that has the most zeros in it, and that's clearly going to be column 2. So we will expand along column 2. Now we need the signs that go with that position. Remember, we started positive, so it's going to go negative, positive, negative, positive, because they always alternate. So I started here. I'm going to write that down, but I'm not going to use that one. Positive, negative, positive, negative, positive. So what we're going to get is minus 0 times its minor, but that doesn't really matter because 0 times anything is going to be 0. That's why this was a good choice. Plus 2 times its minor. Now, sadly, 2's minor is going to be a 3 by 3 because we go down one size in determinants. So if we write the remaining terms we have in row 1, it's going to be 1, negative 1, 2. We lose row 2, it's going to be 1, 2, 3. Sadly, we're not getting any zeros either. Negative 1, 1, 2. Bummer that. Now we're going to go on. It's going to be minus 0 times its minor, and then plus 0 times its minor. So our 4 by 4 has really come down to, can we evaluate this 3 by 3? So we can do expansion by minors. Let's do expansion by minors just to cement that. We don't have any zeros, so there's not really an advantage of one over another. So just for simplicity's sake, I'm going to expand along row 1. So we're going to have 2 times, and then going along row 1, we're going to get 1 times 1's minor. So we delete its row and column. That's going to leave 2, 3, 1, 2. 2, 3, 1, 2. It's going to be a minus the negative 1 times its minor, which is going to be 1, 3, negative 1, 2. 1, 3, negative 1, 2. And then plus 2 times its minor, which is going to be a 1, 2, negative 1, 1. So now we can do these doing our down minus up. So the 2 is still waiting outside. We're going to get 1 times, and that's going to be 4 minus 3. That's going down minus up. Minus negative 1 is a plus 1 times down minus up is 2 minus the negative 3. And then a plus 2 times, and that's going to be 1 minus negative 2. So we're getting here, we're making progress. 2 times 4 minus 3 is 1. 1 times 1 is 1. 2 minus negative 3 is 5 times 1 is a 5. And 1 minus negative 2 is 3 times 2 is 6. And so that looks like 2 times 12. So that determinant is a positive 24. Whew. I don't think we want to do a whole lot of those, but there you have it. Let's move to a new screen and let's talk just about a few things about our determinants. So one is, suppose we had 1, 2, 3, 4. So if we evaluate that, we would go 4 down the diagonal. 1 times 4 is 4, minus 2 times 3 is 6, is negative 2. Now, if we switch a row or a column, so suppose I move the 3, 4 up here and then the 1, 2 there. Same numbers, but I just switched the order of the rows, and this would work for the columns as well. What we're going to see is it changes that sign of the determinant. So every time you switch a row or a column, it's going to change the sign of that determinant. Another kind of interesting fact is if we take something like, let's take our 1, 2, 3, 4, and we multiply that by some constant k. Then the way you take a constant times a determinant is you distribute that k over every entry in there. So that'll become k, that'll be a 2k, a 3k, and a 4k. So now when we evaluate that k times that determinant, we're going to, k times 4k is going to be 4k squared minus the 6k squared is going to be a negative 2k squared. Notice how that compares to the original with before we multiplied by k. So what we see is that multiplying by a constant changes the determinant by that constant squared. Okay, kind of interesting. Okay, I think that's going to be enough for 12.7.